This video is to help you remember how to solve a system of equations. We've got an example here. I'm going to solve it in two different ways, one using substitution and one using the elimination method. Let's start with the method that I think would be easiest for this example, which would be the elimination method. The substitution method works best when one of the coefficients of either variable is 1. We don't have that in this case. We can still use that method, but it would be easier to use elimination. So the way the elimination method works is we're going to add these two equations together. But we don't want to do that just yet, because the whole purpose is to eliminate one of the variables. And to eliminate a variable means that the coefficients of that variable, of the two different terms with that same variable, need to be opposites. Right now, my coefficients of x are 3 and 2. Those are not opposites. My coefficients of my y terms are 3 and 5. Those are not opposites. So I'm going to have to be a little creative here and think of what could I multiply either one equation or both equations by in order to get opposite coefficients. I need to first choose which variable I want to eliminate. I think I'm going to eliminate the x terms. So if I look at them, I've got 3 and 2. I think if I multiply this first equation by a 2, that would give me a coefficient of 6 for my x term. And if I multiply the second equation by 3, I will also get a coefficient of 6. However, I need one of those coefficients to be negative, so I can make either the 2 or the 3 negative. So let's see what happens when we multiply. We're going to distribute that number to every single term in both equations. And we're going to get something like this. In the first equation, we will get 6x plus 6y equals 180. In the second equation, we'll get negative 6x minus 15y equals negative 540. Now my x terms have opposite coefficients, so I know when I add these equations together, the x terms will be eliminated. What's really important before you add them together also is that all of your like terms line right up. I've got my x terms, I've got my y terms, I've got my constants. I like to always put mine kind of like this, but it doesn't really matter. They just need to match, be in the same form. So if I add these together right now, my x terms cancel, my y terms add up to a negative 9y, and my constants add up to a negative 360. What's happened is I went from two equations with two different variables to now I have one equation that has one variable. I can always solve an equation that has one type of variable. If an equation has two different variables like x and y, I will not be able to solve that equation for both the values of x and y. I would need a second equation also containing x and y, such as a system, in order to solve for both values of those two variables. So this equation, negative 9y equals negative 360, would be very simple to solve. I'm going to divide both sides by negative 9. So y equals 4. Now to find my x value, I can just plug in this 4 for y in any equation that I have on my paper. I'm just going to use this second equation right here, just because it's right there. So I'm going to replace the y with the 4. 5 times 4. And then we're going to simplify. 5 times 4 is 20. I'm going to move my 20 to the other side. So 2x equals 160. If I divide both sides by 2, x equals 80. And I have just solved for the value of both my x and my y. Now usually when you see a problem like this, you're not done at this point. You're probably going to have to plug in the x and the y into something else to find some given or some measure that's unknown or some length that's unknown. So that was using the elimination method. Now we're going to try the substitution method. Like I said, it works better when one of your coefficients is a 1, but we'll make it happen here. If I look at both of my equations and I look at the coefficients of my x and y terms, I can really choose either x or y in this case. So I'm just going to go ahead and start with my first equation. And what I'm going to do is I'm going to try to solve for either x or y. I think I'm just going to solve for x. So to do that, I need to get everything to the other side. So I'm going to go ahead and subtract my 3y from both sides. So 3x equals 90 minus 3y. Now to get my x by itself, I need to divide everything by 3, both sides. What's going to happen is we're going to get 1x equals 30 minus y. So what we've done is we've solved for one variable. What this means, this equation is very important to us. X has the same value as 30 minus y. 30 minus y is kind of like its substitute. So what we're going to do is we're going to go to the other equation, and in place of x, we're going to put this 30 minus y. And watch what happens. I need to make sure to put it in parentheses because I'm multiplying it by the 2. If you notice now, this equation only has one variable in it, just y's. I'm able to solve an equation with one variable. So let's do that. Let's go ahead and start by distributing our 2. 2 times 30 is 60. 2 times negative y is negative 2y. I'm going to clean it up a little bit by combining some like terms. Negative 2y plus 5y is positive 3y. I'm going to move my 60 over to be with the other constant. 180 minus 60 is 120. And then lastly, I'm going to divide by 3. So y has a value of 4. Notice that was the same value of y when we used the elimination method. To find x, this is very simple. I'm going to go back to this equation right here, and I'm just going to replace the 4 where the y is. So x equals 30 minus 4, which is 26. Okay, here's another example of a system. This system has quite a few terms. We will also solve this system in 2 ways, but before we decide how we're going to do that, we need to combine all of the like terms. Sorry guys, that was my baby crying, he's sick. So anyways, what I was saying is we need to clean up these equations, combine some like terms, so we can really see what it is that we're looking at. Let's look at the first equation. What we need to do, we need to get our y's together, and we need to get our constants together. So let's rewrite it. Okay, we might want to maybe move this y over here to be with the 4y. So we're going to get x plus 3y plus 10 equals 70. And then we need to move that 10 over to be with the 70. So x plus 3y equals 60. Okay, we're going to do the same thing with the other equation. Let's just go ahead and move this 8 over to be with the 180. So we're going to add 8 to both sides. So we're going to get 5x plus 3y equals 188. Okay, so these are our 2 equations. Notice that they're in the same form. I've got my x terms plus my y terms equals my constants. This is just how the form that I like to put my equations into. Let's go ahead and start by solving this one with the substitution method. Notice that this x right here has a coefficient of 1. It's very easy to solve for x when it has a coefficient of 1, or for y if it has a coefficient of 1. So the way that we're going to do that is we're going to subtract 3y from both sides to move that to the other side. So x equals 60 minus 3y. We have solved for x in terms of y. This expression means the same thing as x. So what we're going to do now is we're going to go to our other equation and we're going to substitute x with that expression. We need to make sure to put the expression in parentheses because we will be multiplying it by the 5. So 5 times 60 minus 3y in parentheses plus 3y equals 188. Now we have one equation that has only one type of variable. This is always what we want to try to get to because we can always solve an equation that contains one type of variable. To solve this, we're going to start by distributing. 5 times 60 is 300. 5 times negative 3y is negative 15y plus 3y equals 188. To solve this, we're going to put our y's together. Negative 15y plus 3y is negative 12y. So we have 300 minus 12y equals 188. All my y's are together, so we're going to move our constants to the other side. We'll move this 300 over by subtracting it from both sides. Negative 12y equals negative 112. I believe that's right. And then the last thing we need to do is divide both sides by our negative 12. So we'll go ahead, a negative divided by negative is a positive. I'm not sure if 12, I don't think 12 goes into 112 evenly, so I might just leave it as a fraction and reduce it. So if I do that, you can reduce that. I know I can easily divide by 2. I think I can also divide by 4. So let's see what happens when we divide by 4. We get 28 over 3, and I think that's completely simplified. So y equals 28 thirds. There's my y value. Now to find my x value, we're just going to plug that y into one of the equations and solve for x. The easiest place to plug it into is into this equation right here. It's already set equal to x. So if we just plug in the 28 thirds for the y, we'll get 60 minus 3 times 28 thirds. Negative 3 times 28 thirds is just going to be negative 28. And if we subtract that from 60, we get 32. So that is the substitution method, another example. Let's take the same example, the same system, and solve it using the elimination method so you could get some more practice with that. Again, we want to make sure that our equations are simplified and in the right form. So if we recall how we simplified them before, we had x plus 3y equals 60 for this first equation, and the second equation simplified to 5x plus 3y equals 188. So they are both in the same form, which is great. Remember how the elimination method works. We want to be able to add them together so that one of the variables cancels out, which means that the coefficients of those two variable terms need to be opposites. So look at what we have. We've got 3y and 3y, which is great. They have the same coefficient. We just need to make sure that one of them is negative. So we can multiply either equation by a negative 1. Let me try that again. Let's go ahead and multiply the first equation by a negative 1. Remember when you're multiplying an equation by a number that you have to multiply every single term by that number? So if I do that below this equation, we're going to get negative 1x minus 3y equals negative 60. Now these two equations right here are ready to use in the elimination method. We're just going to go ahead and add them together. These two y terms will cancel, which is exactly what we want to happen. If neither of your variables gets eliminated when you add the equations together, that means you don't have opposite coefficients on the variable terms that you're trying to eliminate. So you need to take care of that first. And sometimes you kind of have to be creative about what you multiply the equations by. Let's go ahead and add the other terms together. We'll get 4x on the left, and we will get 128 on the right. Now we have a very simple equation that has just one variable. Very easy to solve just by dividing by 4. So x equals 32. To go ahead and find the y value, we're just going to plug in this 32 for x in any equation that we see. And I kind of like this equation right here because it looks very simple. So I'm going to put 32 for my x plus 3y equals 60. And now we'll solve this equation for y. So I'll move the 32 over by subtracting it from both sides. 3y equals 28. Divide both sides by 3. 3 does not go into 28 evenly, so I can just make sure that it is a reduced fraction. I'm just going to leave it as 28/3. Notice this y value and the x value of 32 are the same two values we got when we used the substitution method. Keep practicing this. There are a couple examples in your book they're sprinkled throughout the book with systems. So if you need to practice, just go ahead and find an example that has an x and a y, create two equations, and practice using the elimination method or the substitution method. Let us know if you have any questions.